Well, good afternoon, everybody. My name's Nick Pilcher, and I'm a marine biologist based in Borneo, in Malaysia. And I'd like to acknowledge the invitation to talk to all of you today. And you're probably wondering why a marine biologist that works with sea turtles and sharks and rays might be speaking to you today. And I think that as we come towards the end of my presentation, you might agree that there are some areas in which our worlds parallel, and I think that some of the solutions that each of you are seeking might be solutions that people like myself need. And so what I'd like to do is go through a quick little presentation with you and just roughly go through some of the ideas I have, some of the work that the Marine Research Foundation does, and bring it to a close at the end with some ideas on what some of the potential solutions to that are. So, technology. Some of the challenges to conservation in the marine realm, at least, I'll go through some of these in detail and give you some idea. One of the biggest problems we face is bycatch in fisheries. Bycatch is when a species gets caught accidentally as opposed to the target fish that fishermen would be going out for. Sea turtles drown in nets, all kinds of animals end up being caught in nets and they're not wanted and they're discarded. And very often those discards are dead, and so it's a complete waste of a natural resource. Another issue with some of these big species is direct take. In much of the developing world, there is still a demand for marine species just simply as food. Many people in the Pacific have been eating sea turtles for multiple years, and that is still ongoing. The same happens in Asia and Africa. So direct take, where people are taking either turtle eggs or taking sea turtles or sharks or dugongs, these things continue to occur. Of course, there's an increase in demand with a world population that's already in the 8 billion person mark. You can imagine that the pressure on natural resources has grown, and yet those natural resources haven't been growing at the same rate as humans have. And therefore, there's an imbalance between the number of people that are creating demand and the number of individual species and organisms that can satisfy that. There are issues to do with coastal development. Everybody wants to live by the beach, apparently, and major industries want to be on the beach because they can get cooling water, tourism attractions, hotels, you name it. Ports, mines, access to raw materials, all of this happens along the shoreline. And the shoreline is a very, very delicate marine environment, and one which is, for instance, with sea turtles, it becomes a nesting beach, and the loss of nesting beaches can impact sea turtle populations. Another major issue that often goes unappreciated by the general public is light pollution. And light pollution, such as from this natural gas plant in Qatar, this creates all kinds of challenges to species. It changes diurnal rhythms. It can change the way nocturnal feeders behave. Bats, for instance, that prefer to operate in the dark. With sea turtles, the species I work with, lights like this will attract the hatchlings back inland rather than allowing them to go to the sea, and it will also dissuade adult females from coming out and laying eggs. So there are some serious problems with light pollution in the marine environment. Alongside that, we also have things like destructive fishing, whether it be nets that are deployed around sensitive ecosystems, such as coral reefs, as in this image, or it could be dynamite fishing, it could be unsustainable trawl fishing in very delicate habitats. There are a number of destructive fishing practices which are causing major impacts to some of these very large and charismatic marine species. Another one that comes to mind also is climate change and global warming. And remember that climate change comes in multiple forms. You don't just have an increase in temperature, but you have an increase in the frequency of natural storms. You have an increase in erosion. This is a picture from a nesting beach in Papua New Guinea, where the sea turtles cannot even climb up this steep incline following excessive erosion. So climate change and global warming are leading to problems not just in the poles with some of the Arctic species and Antarctic species, but also in the tropics as the frequency of storms and global temperatures start to increase. Similarly, there is a massive problem with solid waste. Particularly across a lot of the developing world, where waste management programs aren't as efficient as they might want to be or might need to be. And much of that waste ends up floating down through rivers or canals, ending up in the ocean, and then just dispersing across the planet. You've heard of the North Pacific gyre and some of the other major problems, but to be honest, it's little things like a bottle cap or a cigarette lighter or a chair that disintegrates in little baby parts, and those get picked up by animals as potential food items, taken in and then never digested. So the management of solid waste is woefully inadequate in many parts of the planet, but particularly across small island nations and in the developing world, where the ability to do something about that waste is challenging. There's a very good film out on plastics which talks about the fact that people think, well, the plastics will get taken somewhere else. But on this planet, really, there is nowhere else. We're all here. And moving the plastics from A to B just means the plastics are there instead of here, but they haven't gone away. And then this sort of emerging in the conscious mind, not emerging as a problem now, but emerging in today's conscious mind, is this issue of microplastics. And microplastics have been around for decades. It's not a new problem. As plastics get eroded and break down into small particles, or plastics that were used in shampoos and soaps and all kinds of things, abrasives, these all have made their way to the oceans. They're being found in the deepest trenches of the oceans. They're being found in coral reefs, inside the coral polyps themselves. And this is, as I said, not an emerging problem. It's rather an emerging problem in the public consciousness. The problem's been here for a long time. It's whether we are tracking it and doing anything with it. So yeah, microplastics, a very, very large problem. So with that in mind, what I'd like to do is just run you through a couple of projects that we're involved with, and to show you how we try to find solutions to some of the challenges we face. Not everything, we don't tackle everything, of course. But to give you some idea of what we do, we're a very small organization. There are just 4 of us, but we work across multiple sites from the Middle East all the way through to Pacific Islands, all the way throughout Southeast Asia, working on developing environmental solutions to protect large species such as sea turtles, dugongs, sharks, and rays. And I have 3 examples of our projects for you today. One of them is the introduction of turtle excluder devices. Now, sea turtles are reptiles, and so they need to come to the surface and breathe air. But when they get trapped in a fishing net, those turtles are now trapped and they can't surface to breathe, and they end up drowning. But by putting a turtle excluder device in the middle of a net, this is just a metal grid that looks something like this, and you can see a turtle would come along and hit the bars of the net and would be able to be ejected up through a flap and be able to come to the surface to breathe. The problem is that fishermen are very wary of turtle excluder devices because they think that their catch also escapes through this flap. And no matter how much research and demonstration you do, that's something that's always going to be there. And governments are wary of things like this because they're wary of the fishermen. If the fishermen don't vote for the politicians, then the politicians get kicked out of office, and so people don't do things that might buck the system. So what we've done over the last decade or so is we've worked very closely with Malaysian fishermen, but also with the government department itself, to bring them to a common table and to see that there is a solution to turtle bycatch, and there is a mechanism, and that mechanism doesn't have to result in the loss of income. And through multiple demonstration trials and dialogue sessions and workshops, we finally got the Malaysian government to make turtle excluder devices a legal requirement in 2017. And just to give you an idea of what that means in practical terms, we estimate that today in Malaysia, there is between 1,000 and 2,000 sea turtles per year being saved by using turtle excluder devices. And this is just a brief image of how it happens. A turtle swims along, hits the bars, and goes out through a flap and is saved. Pretty cool stuff. Another one of our flagship projects is working to mitigate shark and ray bycatch. Now, typically these species get caught in gill nets, such as in the graphic that's here, or in this one. So both a shark and a ray that have swum into coastal gill nets. But these species also get taken in trawl nets and purse seines and a variety of different fishing gears. And many species are actually threatened with local extinction because of the level of bycatch. And when I say local extinction, I mean that it's not necessarily that species will go extinct today across the world, but it might go extinct today in Malaysia. And many governments just don't have the data they need to be able to design management solutions. For instance, nobody knows when these animals are caught or where. And if you don't know when and where a species is caught, then it's very difficult to design a management solution, such as, for example, a time area closure. So if we knew that all of a particular species happened to be caught in one place during certain months, we could design a solution around that. We could have a temporary access restriction or a temporary gear restriction that would allow that to happen. And so what we have done is we have developed a GPS linked and time-stamped time-lapse camera that we have installed on fishing boats. And as these fishing boats are operating, it takes a photograph every 5 seconds and allows us to determine where and when species are caught. And this particular image on the screen is of value because we have only found 3 of these wedgefish in all of about 1.5 years of research. And all 3 of these have happened within 20 kilometers of each other. And that tells you right away that that particular spot is probably a very important spot for this critically endangered species. And now the government has the ammunition it needs and the knowledge it needs to design a management solution. And here's a couple of other examples. You can see a hammerhead shark, and there are some rays and all kinds of things that we can detect. And finally, as a last example of one of the projects we run, is to introduce you to the impacts, our contribution to studying the impacts of hatcheries and climate change on sea turtles. And you might wonder why this would be important. Well, to start with, the sex of a sea turtle is determined by the temperature of the sand in which the eggs incubate. Yeah. So if the sand is warm, you're going to get a higher proportion of females. And if the sand is cool, you'll get a higher proportion of males. And what this graph is showing is as temperature increases on the lower axis, you can see the proportion of females increases to nearly 100%. Similarly, as the temperatures decrease, the proportion of females decreases down towards 0. And this is one of those great sort of trivia things you can bring out at a party. And if you have trouble remembering which is which, just think of cool dudes and hot chicks, and that should get you remembering all of this easily. But what happened in Malaysia was that local hatchery practices, the management of the parks, had moved all of the eggs into a hatchery that had no shade. And so all of the eggs for about 30 years were just producing female turtles. Well, while those turtles were running down to the ocean and it all looked very exciting and appealing, from a conservation standpoint, if you're not producing males as well, it's pretty much a conservation bottleneck and not a great idea. The park director wasn't willing to change anything because he was convinced that the number of turtles running down the beach was proof of their success. So what we have done is we've run a program where we've caught turtles at sea on their feeding grounds. We've used laparoscopy, which is a small surgical technique, and combined that with genetics to be able to, one, determine the sex ratio of turtles in the ocean, and two, determine where those turtles came from. The simplest explanation is each nesting beach has a pretty unique genetic signature. So a turtle coming from a beach, we would be able to know where that was. Well, what did we find? As we started out this work right at the very beginning, we found we had actually a higher, nearly 97% female in our very first sampling session. That came down a little bit as we ran a second sampling session. And when we we determined that the vast majority of those turtles were coming from those hatcheries. Well, when this information was presented to the park management, then they started to get very concerned. And since then, they've allowed the trees to grow in and shade the beaches. They've put artificial shade over the hatcheries. And as you can see from this graphic, the proportion of females is slowly reducing and stabilizing to something that's a lot more natural out in the wild. The research we do is not aimed at just collecting information for the sake of information. It's aimed at convincing management to change and changing the course of a population outcome. So in this case, had the turtles continued to have females, at some point in the future there would have been no reproduction and this species would have gone locally extinct. But by being able to use the right research tools and provide the right information in the right context to the authorities, we were able to reverse the decline of that population and actually lead to some sort of a population recovery. And when we go out and we see these turtles at sea, we find that there's a lot more turtles than used to be there in the past, and that's why we do what we do. So just to sort of bring this back to where we were at the beginning, we know what the problems are. We're quite aware of what the problems are, what causes them, what the drivers are behind those problems. What doesn't happen sufficiently well is, one, the amazing amount of data that's collected by natural resource scientists across the planet is rarely provided in a way that is useful, and it's in most cases not even used. At the government level, and particularly in the developing world, there isn't really a prioritization of natural resource conservation. And people are much more concerned with 5G networks and high-speed rail and an aviation industry, and yet the survival of the natural resources is pushed all the way to the very far end of the agenda. I'd say that natural resource scientists are largely to blame, because most of the people that are out there collecting this sort of data aren't good at communicating the results and their findings to the people that need information in a certain way to make a management decision. And just putting it in a scientific journal is not going to go anywhere. It's not going to make any difference whatsoever. And so I think what really is needed is natural resource scientists need to be a lot more innovative about how they get involved in conservation and how they move things forward. Really, a lot of things in conservation today and the way data are used are flawed. I'll give you an example from the research data that's out there. I'd say less than 1% of that is ever used to drive management change, to drive conservation and natural resource management. Less than 1%. What an absolute waste. And what an unsustainable way of running the planet. Think of how those resources could have been better used elsewhere or by other people that were willing to communicate effectively and make change happen. And so now, bringing us back to why I would be speaking to you today, and this is where I think that there's a way in which the solutions that natural resource managers need are solutions that you are developing and we are not communicating between us. I think that there is a need to take the data we have today and find ways to translate that into actionable information, things that managers in the developing world can grasp at the tip of their fingers and say, I get it, I can make this change. I think that we also need to make sure that governments prioritize the environment at the same time as they prioritize the developments of nanotechnology and communications and research and medicinal breakthroughs. I think all of these things go hand in hand. And finally, I think there's a need to come up with some innovative solutions to day-to-day life problems. And I don't mean just recycling or putting solar panels on the top of our houses. In much of the developing world, we might recycle at home and those things would all get thrown into the same waste tip later on. So it's not a case of recycling. It really is a case of finding the new solutions. Back in the 20s, nobody thought of plastics as a solution to many of today's challenges. So what I say to all of you is that we might not be thinking today of the solutions that would lead to much better environmental conservation, but that if we start thinking of ways and working towards that, then I think there's a really good future for all of us. And with that, I thank you very much for your time.